So, very good afternoon, my dear students. So, let us continue with the previous session where we stopped in Microcontroller Laboratories, which is a four-sem curriculum in VTU for CBCS scheme of 18th scheme. So, the subject code is 18ECL47. So, in the last class, we have learned the basics of microcontroller, and we have discussed with some of the features of architecture of microcontroller and procedure for creating the project in Keel software in order to simulate your programs. So we have learned one of the basic program in that data transfer, in that block movement, how it is going to happen, how to transfer a block of data from source to destination location. It may be a 5 blocks, or it may be a 3 blocks, it may be 8 blocks, like that. So I have shown clearly in that previous example. So in this session, let us continue with further programs like exchange, sorting, finding largest element in an array, and further. Okay, so let's start. So today program is write an assembly language program to exit or exchange n, that is 5 exa byte of data at location A, that is source location is 30h and the location B is 40h, and this is a program. Anyway, step by step the program I am going to explain while debugging the program. So this is our program, right? So now let us see what are the things or parameters I am going to give for the results. Let us say for the address I am giving D colon 30H. So it's 1, 2, 3, 4, 5. That means 5 data I have stored in source, and in destination 40H I have stored A, B, C, D and E, and the programs is exchange. So before execution in source I am having 1, 2, 3, 4, 5. In destination address I am having A, B, C, D, E. So after execution in source it has to be exchanged. So it should be A, B, C, D, E, and in destination it should be 1, 2, 3, 4, 5. Okay. So let us start with the things. So we have, as I told, we need to double click on Kill Microvision software. So yeah, so this is a program what we have done previously, right? So again I'll repeat anyway, so the procedure and all you'll get to know. So go to project, new microvision project. So here project 2, proj 2. So project 2, save the things, and here what you have to give, simple, you can search 80. So here we have, yeah, go to microchips. Here we can have 8089 C51 RD2, or you can C2 also you can select. Okay, so which processor we are going to use? Okay, Atmos, and it will ask for to copy the startup.a51. We'll just give it as no, and your target is built and your source file is created. Right click on this. So you just give add a new source. So here you give .asm. Here again you give a file. I'll give the same one, prog2.a51. Okay, so add it. In our earlier versions of Keel, it will take it in .asm. Here it is take it as .51. So I need to type the program here. Anyway, my program is ready. I'll copy this thing. So directly there. So we have. So coming to this, yes. So program is ready. So what we have to do is, after writing the program, you have to save the file. After saving the file, build the project. Okay, you need to build the project. After building the project, here you will come to know whether your project is built properly or not. That means if there are any errors, any warnings, they are going to indicate it. How many errors are there on which line? So here total the program is how many lines? It is 13 line program. So you can notice that no errors are there, right? So now you can notice the errors. After noticing the errors, so after if the build is successful, go to debug. give the start debug session. It will give a caution like evaluation mode running with code size. You just give it as OK. Once it enters to the uh, debug mode, here we have register things like we have our register 0 to register 7, everything, the data what is given. So here we have call stack and all location, but we need to have the memories first. So go to view, because we are dealing with here exchange program. We deals with two memories. One is source memory, another one is destination memory. So go to view, memory window. Memory window one is there already. You take two. So one is already there. Two you take. In one, according to our program, what we have to take before execution at 30H. Why 30H? Because in the program you are given 30H as a source address. So D colon 30H. You just enter and see nothing is there. If anything is there like here FF07 and all, these are garbage values and 1110 and all. Okay, don't worry, you just type it as 1, 2, 3, 4, and 5. Now you tell me in 30H what we are having 1, 2, 3, 4, 5. That data is nothing but the data is in source address, that is this one. Why I am giving only 5 data? See here, because the counter value is 5, the number of data to be exchanged, I am considering it as only 5. If I take 6, n is equal to 6, and if I store 5 data, this value also will be considered as 0. Okay, and it also been exchanged. Got it? In memory too. What is the memory address? See, 40H. So D 40H. Enter. So here A, B, C, D, E. Okay. So now we have A, B, C, D, E in destination address, and 1, 2, 3, 4, 5 in source address. So let us execute step by step. As I already told in the last video also, you can run the whole program here and you can see the output directly in 40th location, that is destination address. The data like 1, 2, 3, 4, 5 will be present, and in source address we'll get these data because we are going to do exchange program. Okay, so let us do step by step first. So this is the step by step, and you can notice the changes in the register, how it is going to happen. See, R0 is having 0 0. After executing the first line, see, it is becoming 30H, that is source address. After executing the second line, R1 will become 40H, R7 will become 05 because the counter value is 5. So move A, it is having a at R0 value. At R0 means the first value we are having it as 1. So in accumulator we are having the value as 1, that will shift to A. So see here, this will become 1, correct? And you can see the program status word is also become 1. Why? Because the parity is 1 now. Okay. So next, see what happens. So the data what is there in A, that is going to R0. So R0 is getting, at R0 is getting 1. So R4, what is there in R4? 1. That will be moved to A, that is A, because in this is the data what we are having. So that is moved to R1. Okay. Now increment R0, increment R1. So increment R0 means this data is already came here. It has to see here. Initially it was here 1. Now after this many lines, already it is replaced by A. What we need to replace next 2? That's the reason we need to increment R0. That means next address. This 30 will become 31. Increment R1 means this one, destination address. This 0B should be here now. So that's the reason. Decrement and jump if R7. This will become 4. So see here, this will become 4 now. Okay, and it will come back to gear back till it becomes 0. It's keep on rotating. That means 5 times the loop will be executed, and all the 5 data will be transmitted from source to destination. That means it will be exchanged from source to destination. Got it? That how the program exchanges takes place. Okay, one more thing I'll show. Just keep on have a look. See, this will become B. Okay, see the register changes, how it is happening. 0B is here now. See, see here, AB has there now. 3 4 only left. So I'll just check now. Okay, so at 30th, that is source address, ABCD is there. At destination address you have 1 2 3 4. Okay, so like this the data are going to execute it. So let me change some things like in our program how we are done in previous month. So I'll change it as 8. Again I'll build, because whatever the changes you make in the main program, kindly save it and rebuild the project, then only you proceed. Please kindly remember, rebuild the project once again and check for errors and warning, then you go for debug. So as you enter to debug session, you know already for 30H, since I am taking n value as 8, I'll take some values like 11, 22, 33, 44, 55, 66, 77, 88, 99. For testing purpose only I am taking 9 values, but my data it's only deals with only 8 values. Okay, here I'll take it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sometimes only 7. Okay. So after this, what I am going to use, instead of going step by step, I'll just directly execute. See, check. Its source address 1, 2, 3, 4, 5, 6, 7, 8. 99 is there, but it is not touched. It is as it is. But here 11, 22, 33, 44, 55, 66, 77, 88. And here 9 10 is also is there, but it is not touched. Why? Because the counter value is 8. Like this, you can give any of the address, any of the data, how many data, counter value, everything you can set and exchange the value. That is, you can exchange the data from source address to destination address. That's how it is going to work. So let us go to the another program, how it is going to deal with. I hope you are understood nicely, right? So another program is write an assembly language program to find the largest element in an array of n bytes at location 4000H. Store the largest element at the location 4062H. This location also, it's your wish. You can take any location, but you have to mention that in your program. Okay. So what you are to going to do here? You have to find the largest element in a given array. In a set of array, you have to find which is the largest number, and they are given the location as 4000H, and that largest number has to be stored in some address, that is 4062H. Okay, so let me go with the things how it is going to happen. So here, as usual, how we are going to do: project, new project, give some name, don't give any extension, 8089 C51 RD2. No, Right click, add new source, .asm, A51, copy, okay. So here the length of array is 6, starting address is 4000, okay. So here what they say is that it indicates the length of the array, this indicates the starting address, data pointer is given to a, that is move x. When you are dealing with data pointer you have to give it as move x. Then that accumulator value is given to r1, incrementing the data pointer, okay. Then after that again resetting the borrow flag. Next you the number in the array have to check, and other new previous larger number you have to check, okay, like this, the step by step, and the answer should be stored in 4062h. That is the location we are given. Save this, build it, check for errors, no errors, okay. So now after checking the errors and warning, let us go to debug session. So as usual, give OK. So now what we have to do is memory 1 we have, memory 2 window let us take view, okay. After that what we have to do again, so in the program what we have in 4000h, here we have to take x because we are dealing with the DPTR, that is data pointer register, and 4000h. Why we have to take 4000h only? Because here we have mentioned it is starting address is 4000. So here it is x colon 4000h, enter, and you give data here 1 2 f 3 4 5 1 2 3 4 5 6, because the length of the array is how much? 6. So 6 data I given. So after giving the data, only thing is we need to run and we need to check. Here let me check. Here x colon 4062h. Why 4062h? Before execution nothing is there, because see the location of result where it will be stored. So I'll execute now. See the fh. So out of this array 1 2 f 3 4 5, the largest number is f, okay, understood. I'll change the values. Okay, I changed some values. So which is the largest here? Again ff is the largest. So let me check. So again nothing has been changed. So let me come back from debugging. Okay, again I'll go back. After going back, so I'll give here again. Okay, so here our expected result is ff. Okay, got it. So this is how actually your program is going to work. So find the largest element in an array, that is the total array size is 6. So now in this manner you are going to get the 6 out of 6 arrays, you are going to get what is the size of the things, like what is the size of array is 6, and out of 6 ff is the highest one, right? So fd and fe may be there, but the highest one is ff, because out of 8 bit ff is obviously highest, right? F is again is not the highest compared to this, because previously it was highest, right? it compares with an array. Okay, so this is how the program is going to happen for this finding the largest element in an array. So next program is write an assembly language to sort an array of n bytes of data in ascending descending order, store them in the location 9000 and use the bubble sort algorithm. So here first we need to understand the bubble sort algorithm, how it is going to work. The bubble sort is a simple algorithm which is used for sorting a given set of n elements which provides the form of an array, the n number of elements. Okay, this bubble sort compares all the elements one by one and sort them based on the values. This algorithm you already studied in your first year also in your C lab. Same algorithm, only thing is we are here using for microcontroller, that is assembly. There you are using for C. Okay, in C++ if I write also this algorithm is same. In Java also it is same. The concept is same. Okay, only the programming pattern and things are different. Language is different. Okay. It is known that the bubble sorting because it is very complete iterative large element in given array. The bubble up towards the last place or highest index, just like a water bubble, rise up to the water surface. So how the implementation of algorithm takes place? First, we have to follow this step. Starting with the first element, index will be considered as 0 and compare the current element with the next element of the array. Initial index it is taken as 0 and compare the current element with the next element of the array. If the current element is greater than the next element in our array, then we have to swap them. If the current element is less than the next element, we have to move on to the next element and we have to repeat the step number 1. Okay, let us consider an example. An array is having 5, 1, 6, 2, 4, 3. If I do bubble sorting, you know that 1 is smaller, so it should come first place. 2 is here, 3 will be here, 4 will be here, 5 will be here, and 6 will be here. That means out of this array, 6 is the very largest. Next largest is 5, next is 4, 3, 2, and 1. So that's how it has to happen. But this is the array they are given. So below we are showing here how it's going to happen. In the first state, that is step 1. So it will compare with the current value is 5 and the next value is 1. Since 5 is greater than 1, so interchange. So it will swap. So here 1 will be there. So 5 will come here, 1 will go here. So it will compare 5 and 6. Since 5 is less than 6, so no swapping is happened. So 1, 5, 6 is already there. Now it will compare 6 with 2. Since 6 is greater than 2, it will swap. 6 will go here, 2 will come here. Okay. So after that, again, it will compare with 6 and 4. So 5 will be here only. Don't worry, in first iteration. So 6 again greater than 4, it will interchange. So 6 will go here, 4 will come back. Again, it will compare with 6 and 3. So interchange will be there because 6 is greater than 3. So 6 will go to the last stage, 3 will come to the this stage. So this is the first insertion. Similarly, after all the iterations, the array gets sorted. So as we can see the representation above, after the first iteration, 6 is placed at the last index, which is correct position for it. Similarly, after the second iteration, 5 will be the second last index. This is how the actual bubble sorting algorithm is going to work. So same thing, I'll take the concept. So we'll execute the program. This is a program. So similarly, so let us execute. So come back from the debug session. So stop the debug session. So let me close this program. Again go to project, new project. I'll give some name, no file extension. So here 80, 89, C51, RD2. No. Next, add, right click, add source, ASM, prog4.a51. So it is there, copy the program. So array size is again 6. The program is copied. So we have 6, n is equal to 6. So save, build, no errors and warning, correct? So wait. So go to debug session. In debug session, since you have taken the value as 9000H, So in the memory, what we have to give? 9000 H. So view. Okay. So these values are given. So it is already there. Only thing is the sorting has to happen. So just I will give. See here. 1, 2, 4, 5, 6. See here. So 1 is the lowest one, then 2, then 3, 4, 5 and 7. That means this is in ascending order because from lowest to highest. If I want in descending order, just come back, debug, stop the debug. So here JC for descending order. So JNC we make it as JC jump if carry. Save, build, no errors, come back, execute again. 2, 5, 1, 7, 8, 9. Okay. So let me give the so 9, 8, 7, 5, 2 and 1. This is in descending order. This is how actually it will work. So this is for descending order, this is for ascending order. Here it will do bubble sorting as I already told. So it is going to compare the present value with next value. If it is greater, it will exchange. If it is not greater, it will keep it as it is and will go check for the next one. So each bit by bit it is going to check. Okay. I hope you understood. I will stop at this point. Thank you.